All right, in this video, we're discussing how to rationalize the denominator of a rational expression. So looking at this first example, example A, we have 10 over the square root of 5. When they ask you to rationalize a denominator, they're telling you that you want to remove the radicals from the denominator of the fraction. So the way to do that here is going to be to multiply the top and the bottom of the fraction by the same radical you see in the denominator. So you're going to multiply the top and bottom by square root of 5. Now, the reason why it's okay to do this is because the square root of 5 over the square root of 5 is just another form of the number 1, right? Because anything over itself is just 1, and if you multiply 1 times any number, you're not going to change the value of that number. So I can do square root of 5 over square root of 5 times 10 over the square root of 5 without altering anything. Now from there, to see what the result of doing this is going to be, we're going to do 10 times the square root of 5. That's going to give you, of course, 10 square roots of 5. And then in the denominator, we're simply going to get 5 as our answer. And the reason why this happens is because whenever you multiply a square root by itself, what's going to happen is the insides get multiplied, right? And you'll end up with the square root of 25, right? Because 5 times 5 is 25. And then you know the square root of 25 is just 5. And this will always happen when multiplying a square root by itself because, of course, that's the same as squaring it. And you know that squaring a square root basically removes the radical sign. And then from there, to finish this problem up, all you're going to do is simplify a little bit here. You can say 5 goes into 10 twice, giving you 2 square roots of 5. All right, for the next example, we have the square root of 8 in the denominator. And as we saw before, we'll just multiply top and bottom by that square root. So square root of 8 over the square root of 8. And then, of course, we know the denominator will just be 8. And then in the numerator, we'll have negative 3 times the square root of 8. Let's look at example C and D now. So in these two examples, example C and D, we have binomials in the denominator, which means that we're going to have to rationalize the denominator using something called the conjugate pair. So what that means is we're going to multiply the denominator by the same thing we see in the denominator, basically, with one small change. Instead of multiplying everything by the square root of 5 plus 2x, we're going to multiply everything by the square root of 5 minus 2x. So we're changing the sign in the middle. That's the conjugate of square root of 5 plus 2x. We just do the same binomial with a different sign in the center. And now what this is going to do for us is it's going to set up in the denominator here a difference of two squares product, right? In other words, we can get the answer by just multiplying the first terms together. Square root of 5 times the square root of 5, as we saw before, will just give you 5. And then you can multiply the second terms together, and that'll give you minus 4x squared. Now, for the numerator, it'll end up being the square root of 3 times the square root of 5 minus 2x. Okay, now the last thing we want to do in this case is to distribute in that square root of 3 perhaps. So if you were to do that, you would have square root of 3 times square root of 5, which is going to give you the square root of 15. And then the square root of 3 times negative 2 is negative 2 square roots of 3, and that'll be times x. And then in the denominator, we will have 5 minus 4x squared. And that's it. Now for the final example, example D, it's very similar. We have a binomial in the denominator, so we're going to multiply by the conjugate, and that'll be multiplying the numerator and the denominator by the square root of 7 plus the square root of 3. Square root of 7 plus the square root of 3. Now when you do that, in the denominator, as we saw before, you'll just get the product of the first terms. Square root of 7 times the square root of 7, as we know, will just give us the answer 7. And then a negative square root of 3 times a positive square root of 3 will give you a negative 3. So the denominator works out really nicely to simply be 4, right? For the numerator, though, we have to square the binomial, square root of 7 plus the square root of 3. So I'm going to write it down twice and then perform the multiplication. Okay, so continuing here, the denominator will be 4. But for this first product, we'll have the square root of 7 times itself, which is just going to give you 7. Then the square root of 7 times a positive square root of 3 is going to give you a positive square root of 21. Then square root of 3 times the square root of 7 is going to give you a positive square root of 21. And then lastly, positive square root of 3 times positive square root of 3 will give you just 3, right? Multiplying square root of 3 by itself will just give you the answer 3. All right, so continuing on some more, we're going to have 7 plus 3 to tell us that that answer is 10. And then we have 2 square roots of 21, so it'll be plus 2 square roots of 21, and all of that will be over 4. Now the last step here is to simplify if possible. Notice that both the 2 and the 10 in the numerator have something in common. They both have a 2. So we can factor out a 2. 2 goes into 10 5 times, and it goes into the 2 in front of the square root of 21 1 time, just leaving you the square root of 21. And then the denominator has a 4 in it. Last thing we need to do then is to divide both the 2 here by itself, giving it a 1, and the 2 into the 4, giving you a 2. So my new fraction or rational expression becomes 5 plus the square root of 21 all over 2.